Now that we've put the issue of whether x is positive or negative, and we've seen on the number line what it means that x is negative and that x is positive, I think it's a good time now to talk about inequalities in general, and we're only going to look at the x-axis and see how do we represent inequalities. The first case is to look just at the point A, which is at x equals to 4. But look at the point. It is an open circle, and in the language of mathematics, this means that this point is not included in the values that we are dealing with. So we're dealing with all the real values of x along this number line. Hence, we've got x is an element of R, but we are excluding x equals to 4. So we've got x is not equal to 4 to indicate that this point is not included. You will see this a lot when you deal with other inequalities, as you deal with graphs and other functions that you will deal with. But it's important to understand, once you see an open circle, it means that point is not included. When you talk about asymptotes, you will see it will be represented in this way, even if it is a dotted vertical line, but it will mean that that particular point is not included on the graph. And we can write this in the set notation as x is less than 4 or x is greater than 4. So we're representing either side of the point. So on the right hand side, we say x is greater than 4, and on the left hand side, we say x is less than 4. But this is not an ideal way of representing this, and x is an element of real numbers. X not equal to 4 will be the best way to represent it. Next, we look at the numbers which are on the left-hand side of A. So because they are on the left-hand side, we know that those numbers will be less than the value of 4. So we therefore say x is less than 4 to indicate that these numbers are less than 4. Now remember, this does not mean that the numbers are negative. They can be numbers that are positive. It's only when it's x less than 0 that we say the numbers are negative. In this case, it's just x is less than 4. So those are the numbers on the left hand side of A. And if we go to the right hand side, you will see that these are numbers which are greater than 4, and therefore the x values that we are talking about is x is greater than 4. So it's important that we understand that. Remember, it's about the number line. Whatever number is on the right will be greater than the number on the left. But I also want you to look at the way I put the sign, the equality sign here. I always put it such that this part which is closed is on the left and the part that is open is on the right. This is by no means the notation that is compulsory, but it makes it easy because I always know that the number on the right will be greater than the number of the left. This always confuses some people, and in order for you to always know you are on the right path, if you've got this open part facing on the right, you know the number on that side is greater, and you've got this closed part on the left, you know that the number on the left is less. You can see also with the case of x is less than 4. I've got 4 on the right hand side where it's open because 4 is greater, and I've got x on the left hand side where it is closed because x is less than 4 in this particular case. Now that we have the basics, let's look at the inequalities on the x-axis. Now, the important part here is to see here, I is the point where the inequality starts, and of course it is shaded in this case. And once it is shaded, it means that it is included in the solution. So we've got an inequality, or we've got values on the left-hand side of -4, but the 4 is included as part of our inequality. And in this case, we've got x is less than -4, but we also have x is equal to -4. So we refer to this as x is less or equal to -4. On the other side, we've got k, which starts at, or we've got an inequality that starts at 1. And of course, we're looking at values which are on the right-hand side of 1. But if you go to L, you will see that L is an open circle, which means that L, or the point L is not included, or the number 8 here is not included in our inequality. So we're looking at all values between k, starting from k, up to L, but not including L. And we write that as x is greater or equal to 1 to include k, which is the point 1, and less than 8, but we do not include 8 and we do not have less than or equal to. And of course, we can write this in set notation. Here we've got x is an element of minus infinity, see the open bracket because we can't include minus infinity, to minus 4. And look at the square bracket, which indicates that we have 4 included in the solution. This square bracket represents the or equal to part of this inequality here. And on the other side, we've got x is an element of, look at the square bracket again, where we are including 1, and it's from plus 1 to 8, but 8 is not included. So the open circle is actually represented by the open bracket here, or by the curly bracket, as you can see here. So it's important that you can sort of represent this correctly. Remember, the open bracket here means that it's just less than, or it's greater than, but it cannot be or equal to. And it also means that this is an open circle, which means that this point is not included. On the other side, the square bracket means that it's less than or equal to, or greater than or equal to, and we have a shaded circle here. So it's important that you note these and you can always remember them when you're required to. Alright, as we discuss these inequalities, it would be nice to look at where do we apply them and how do we apply them. And in this case, we've got a graph, which is the graph of y is equal to plus or minus square root of x, or which is just the inverse of the graph of x squared. So this is the inverse of a parabola. Now, if the question asked you to find the domain of the graph, it will in fact be saying what values of x correspond to the graph. And if you look along this line, all these values of x correspond to the graph. And how do I know that? It is because I can draw a vertical line that will cut the graph and cut on these x values. Now, if you go here and try to draw a vertical line, it will not cut the graph, and these values are not part of the graph. So these values start from m and they go on to infinity. And remember, m is included in this case, and therefore x is greater or equal to 1, or we can write x is an element from 1, including 1, up to infinity. And remember, we've got an open bracket for infinity because we never can include infinity since it is not a definite number. Let's look at these inequalities that we've talked about on a practical situation. We've got a graph of sine here. This is a graph of sine, and as you can see, it goes on and on to minus infinity, and on this side it will go on and on up to plus infinity. It is not bounded and it will go on forever. But in general, when we deal with trig equations, this graph will be bounded by a specific domain. Now, if you look at this situation between the point P, which is minus 90, and K, which is 180, we can have a graph. And in that case, we will then have bound our domain to between minus 90 and 180. And if you look at what we will draw, this is what our graph will look like. It starts at minus 90 for the x values up to x equals to 180. And I guess you can write the inequality that represents this line from P to K, which will actually be the possible values of x for this particular graph, which is between minus 90 and 180 degrees. Now remember, the point P is included, so you will have to decide on the equality sign that you use, as well as the point K is included, and you will decide. And think about also, how do you write this in set notation? What kind of brackets are you going to have? Are you going to have open brackets or are you going to have square brackets in order to represent the inequality correctly? So these things that we are learning as basics are what we will apply when we deal with questions that are of the level of grade 11 and 12. And we need to understand these basics in order to be able to answer the questions.